Okay, so this one is rectangular hyperbolic functions, which sounds kind of scary. You've done these before. You call them rational functions. For whatever reason in our book, they're called rectangular hyperbolic functions. So a hyperbolic function consists of two curves that are called branches. So in my picture here that's in color, the blue curves there are your branches. The parent function for this is f of x equals 1 over x. And sometimes that's called the reciprocal function. The graph has a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. Your domain in set notation is d is equal to x, is a set of all the real numbers where x is not equal to 0, and the range essentially the same thing. 0 obviously makes the bottom of your fraction undefined, so x cannot be 0. Y cannot be 0 because no matter what number you plugged in for x, you are never going to get 0. So in this course, we're going to concentrate on equations that are of this form right here, which essentially means that we can do a transformation to our parent function. So the A is a vertical stretch. You're multiplying that fraction times a number, essentially. That's going to stretch the graph vertically. B is a horizontal shift. So just like we talked about before, that's going to move the graph in a little bit of a different way than what you would think. We'll talk more about that in a minute. And then the plus C is going to move the graph vertically. It also shifts the asymptotes. So for example, the graph down here below, this graph is just shifted of this graph right here. So in this case, the graph, the horizontal asymptote has shifted up 2. So that would be y equals 2. The vertical asymptote has shifted to the left 4. So that would be x is equal to negative 4. This would be, and this is assuming no stretch, the new equation would be f of x equals 1 over x plus 4 plus 2. Now your domain in set builder notation would be x is a member of all reals such that x is not negative 4, and then such y is not 2. Now I don't care if you just say domain x is not negative 4 and range y is not 2, but that's what they use in the book, and I didn't want it to be confusing to you. Okay. Now, one thing about finding these asymptotes, you can just shift them, doing what we just talked about, but you can also find the vertical asymptotes by setting that denominator equal to 0. So x plus 4 equals 0 gives me x equals negative 4. That's my vertical asymptote. To find the horizontal asymptote, you're going to plug in super big numbers for x. So if I plug in, say, 1,000 on the bottom of that fraction, I'm going to have 1 divided by 1,004, which is essentially 0, plus 2 means that my horizontal asymptote is 2. So you can always do that if you can't remember how to do this shift. So, for example, let's say we want to graph 1 over x minus 2 minus 3. So that minus 2 on the bottom is going to move my graph to the right. Sorry, this is kind of funny looking over here. But it's going to move the graph 2 units to the right. So this is where my asymptote moved. And then the horizontal asymptote is going to be moved down 3. So that's where the horizontal one would be. And I forgot to fix my domain and range here. I copied and pasted it. This should be x is not 2 and y is not negative 3. Now when you're putting these in the graphing calculator, which we'll do here shortly, make sure that you put that entire denominator in a parenthesis, otherwise it will not graph correctly. I think most of you should be good here, but there are some older graphing calculators that connect the branches. So this is not the same graph as up above, but you can see the branches right here. There's one branch and there's another branch, and it's connected in the middle. That line in the middle is actually your asymptote, which in this case looks like that would be at about x equals negative 1. Okay, so let's, this we're going to do without doing any graphing calculator, at least here for a minute. For the first graph, my vertical asymptote, that's going to be, again, essentially what makes the bottom equal to 0, but the vertical asymptote, that's going to be the one that goes up and down. So that's going to be affected by shifting left and right. So let's do actually the transformations here first. This graph's going to go left 1 and down 2. So it's going to take my vertical asymptote, okay, which normally goes this direction, that's the one that is affected by a shift left or right, that's going to now be y is equal to negative, x is equal to. That's also what makes the bottom equal to 0. The horizontal asymptote, that's the one that goes this direction. That's going to be affected by moving up and down. So this one's going to be y is equal to negative 2. That's affected again by plugging in, say, 1,000. I have 1 over 1,001, which is essentially 0, minus 2. My horizontal asymptote is negative 2. Okay, so if we put these on paper here, x equals negative 1. Okay, it's going to look like this. Y equals negative 2. It's going to look like that. It's just a matter of figuring out where the branches go. So we can go to the calculator for that. Okay, so let me clear this out here. All right, so we go to y equals, and we hit clear, and we type in 1 divided by x plus 1, and again, make sure that's in a parenthesis, minus 2. So there's my branch, and there's another branch. Now, the calculator does ask you to plot some points, so we could totally just sketch this. Actually, let's just sketch this one. We'll do the points on the next one here. So we're going to have a branch right here, and we're going to have a branch right there. That's good enough for now. Okay. The next one here is going to go right 1 and up 3. So my vertical asymptote is going to be x equals positive 1. Again, that's what makes the bottom equal to 0. And then for my horizontal asymptote, y is equal to 3 because the graph moves up. So y is equal to 3. Right 1. Okay, so let's throw this one in the calculator here real quick. Minus 1 plus 3 and double check. Yep. Okay, hit graph. So this one kind of does the same thing, at least as far as where position-wise, where we've got these things. So we've got one that's here, and we've got one that's there. Oh, sorry, I shouldn't have gone so fast there. Okay, so these last few here, looking at A, we can tell a little bit just from looking at this one. I know that I'm going to have a horizontal asymptote at, a vertical asymptote at 2. Okay, because the graph is going to the right, we're shifting and that's what makes the bottom equal to 0. Okay, we're moving the minus 4, we're moving down, 1, 2, 3, 4. And again, if I plug in a big number like 1,000, I end up with essentially a negative 4. Okay, now the 3 is going to stretch this one vertically. So I don't know how much you'll be able to tell in the calculator that it's been stretched, but let's get us some points for this one. All right, so y equals 3. Just kind of type over what I already had here. 2 minus 4. Okay, so here we graph. Okay, now this time let's see if we can plot some points. It'll probably tell you how many points they would want you to plot. Okay, so kind of just looking all the way out to 10 here. Okay, nothing really great. But we could say, let's do a little chart here. So we're going to have negative, there we go. Okay, so we're going to have, say, negative 10, negative 4.25. We have negative 1, negative 5. 0, negative 5.5 is a good one because that's actually a y-intercept. Okay, sorry about that. The calculator froze up on me. So I went ahead and moved the table down there. So I've got 1, -7, so that's a really good point. Then where it says error, that's where I have an asymptote. So I have 3, -1, 5, -3, and then maybe, I guess we could do 10, -3.6. Okay, so let's try to plot these here. We've got -10, -1, 2, 3, 4. So maybe something like that. We've got -1, -5, 0, 4, 5.5, 1, 4, 5, 6, 7. And then we're going to jump on the other side there. We have 1, 2, 3, -1, 1, 2, 3, 4, 5, 1, 2, 3, and then 10 is about something like that. Okay, now look at what the actual graph's supposed to look like too. Okay, so that's giving us our branches down there. So we're going to go through those points. We're going to go through those points, and then just kind of fill in the blank with what we have left. Okay, the last one over here. Now again, I'm not sure how much of this they're going to expect you to do by hand, but here's how they do this type of question in your book, and this is the last few questions that you're asked to graph. So I can type this into the calculator, and I'll show you how we would do that here in just a minute. But they want you to think of how this relates to the original function, which was something like 1 over x minus, use the same letters, I'm sorry, a x minus b plus c. Okay, so in this case, they are trying to make this be two things that are being divided potentially. So the 4x on the top, let's think of that as being 4x plus 0. And instead of actually being 0, let's think of it as being plus 8 minus 8, because of course that's the same thing as 0. Now, focus on just this. I want to see if I can make it so that I can divide those two things nicely. So I could factor a 4 out of that first circle, and that gives me this. And then now I can cancel that x plus, not cancel, but I can divide. So what happens is we're dividing these two, but then we're also dividing these two. So when I divide these two, okay, I have this, and then I have this. When I divide the red, the x plus 2's cancel out to just give me 4. And then this would stay the same, of course. You can flip that around, and it looks like this here. So in this case, I have a vertical flip and a stretch of 8. That's what the -8 is going to do. It's going to move it 2 to the left because of the plus 2 on the bottom, and it's going to move it up 4 because of the 4 in the front. So that means we have a horizontal asymptote of 4 because that it's going to move up, and then we have a vertical asymptote of -2. So let me go ahead and put those in here. -2, and then 1, 2, 3, 4. Okay, so you can type that one in that way, but let me actually show you how you would do it the other way. In this case, you're going to want to have the entire top and the entire bottom in a parenthesis. When it's just one thing, that's okay, but if you've got more than one thing, you really just need to put the whole thing in a parenthesis. And it's not going to hurt if you just have one thing on the top and you put it in a parenthesis. Better safe than sorry. Okay, so there's one curve. And there's the other curve. Now again, you can't see those asymptotes, but you can kind of estimate them somewhere in this gap. Okay, which looks like, yeah, -2 would work. And then 1, 2, 3, 4. Okay, that's where my horizontal one is. So if we look at the table here, and again, we look for some good numbers. Okay, so actually 10 was a really good number. So I can do negative 10, 5, negative 6, 6, negative 4, 8, and then the next one is too big. I can do negative 1, negative 4, I can do 0, 0. Two, 2 is a good one. And 6, 3. Okay, so we can do 2, 2, 6, 3, and that's good enough. Okay, so we actually have quite a few. So negative 10, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, and negative 1, 1, 2, 3, 4. Now we're on the other side. 0, 0, 2, 2. Okay, so here's one branch, and here is another one. And that is rectangular hyperbolic functions.